Hi everyone. In this video, we will discuss some important networking concepts. So, first of all, what is a network? Uh, Network is something in which our computer devices communicate with each other, and that network can be a complex network or a very simple network in which just two devices are communicating directly through a cable or some wireless connection. So if some devices which can be your computer or which can be your mobile phone or anything which can be connected to the network, if they are communicating uh, through some channel, then that is a network, right? And one of them is in which we are interested is LAN network. So LAN is a limited area. So it stands for local area network. So this LAN network is established within a limited area, and that can be your home, where you have your router and all of your mobile phones and laptops are connected to that router. Or it can be your college campus. It can be your college campus. It can be your school. It can be a lab or anything which is of limited area. So it can be a single building in which devices are communicating with each other. So in your college campus, lots of printer and computer devices are communicating with each other. They are sharing memory, they are sharing messages. So that limited area of network comes under our LAN network. Okay, now let's take an example for it. So this is a LAN network. You can consider it as your home. So in this LAN network, we have two laptops here and one cell phone we have. And in LAN network, uh, we have IP address which is assigned to every device. So this laptop has this IP address, and this laptop has this IP address, and this cell phone is having this much IP address. What is an IP address? I'll come to it soon, but for right now, just understand that there is something called IP address which is associated to each device, and there is something called MAC address which is also associated to each device in your network. Okay, and there's something called network IP address which is assigned to your entire network, which is your, of course, LAN network. Now, before decoding it further, like what you must be wondering, what is switch and what is private IP address and what is this my MAC address. So before proceeding with that, let me first introduce one term, uh, that is node. So the term node can be used for the computers or your mobile phones, or it can be used for the routers or switches. Okay, what are routers, what are switches? I'll come to it soon, but node is the term which can be used for all those machines which are present in your network, uh, we usually uh, denote them by this term node. Now let's come to the IP address. What is an IP address? Now here you can see that we have IP address for each device, right? Also, switch also has an IP address. So every node has an IP address. So first of all, every node has an IP address. This IP address uh, identifies a node. It is different for all the nodes. Two nodes um, do not have same IP address. So uh, IP address is an identifier of nodes. So here you can see that for this laptop we have 192.168.1.1, and here we have .1.2 IP address. So this IP address is different for different nodes. Great. So one also, this IP address is not fixed. It can vary for a single node. For a single node, it may change. So it may happen that when you are at your college campus, in that local area network, you may have some different IP address, but when you come to your house, when you connect to um, your own Wi-Fi router, uh, in that network you may have some different IP address, right? So this IP address uh, changes based on the location of your node, and it identifies your node within a network, right? So in a network, each device has a different IP address. So IP address, it is like a phone number. uh, when you have to communicate with your friend, you have to use you use a different phone number, contact number to connect with your different friends. So similarly, in computers or in nodes, they use IP address in order to communicate among them. So IP address is like a contact number, uh, by using nodes can communicate among them. Now, one more thing, this IP address is represented by 4 octets. So we have octet 1, octet 2, octet 3, and octet 4. Octet 1 dot octet 2 dot octet 3 dot octet 4. And what is an octet? Octet is nothing but a set of 8-bit binary number. So we have 8 bits of uh, 8 bits of binary number here. Similarly, 8 bits of binary number here, 8 bits of binary number here, 8 bits of binary number here. So this IP, more specifically, this IP address is nothing but IPv4 address, if I say it. So people now are currently using these four octets to represent an IP address. So that's why it's called IPv4 address, and it can be uh, represented through binary notation or decimal notation. So let's say for octet 1 I have value 198, and for octet 2 I have value 10. For octet 3 I have value um, let's say 1, and for octet 4 I have value 2. So this is decimal notation. 198 is a decimal number, 10 is a decimal number, 1 is a decimal number, 2 is a decimal number. So this is decimal notation of my uh, IP address. Uh, and this 198, so each such number is represented by each such number is represented by a set of 8 bits, right? So we know that when we have maximum 8 bits, so we can have maximum number 2 raised to power 8, right? So 0 to 255 we can have decimal value for each octet. So for this IP address, 198's decimal equivalent is 11000110. And for 10, its binary equivalent is 0001010, and for 1 it will be 7 zeros, then 1, and similarly for 2 it will be 6 zeros and 1 0. So this is the binary representation of my IP address. All right. So this is my IP address. It identifies a node. It is different for different node. It is represented by 4 octets, right? And now you see here that I have used the word private IP address here and not the public IP address, right? So we have something called private IP address and public IP address. And why are we making our IP address public sometimes and sometimes making it private? That I will also come to it soon, but before that, let's discuss what is MAC address. So MAC address is also something like IP address. First of all, it also identifies our node, right? So it is different for a different node. And one peculiar thing about MAC address is that it never changes. Even if you change your location, whether you connect to your network of your college campus, or whether you connect your device to your house Wi-Fi router, it never changes. For it is written in your physical hardware of your device. So basically we have something called network interface card, which we call NICs in short. So for each device we have a network interface card in which this MAC address is written, and it is unique for each device. So every single device in this world has a unique MAC address, right? And it is represented by 48 bits, right? So okay, so we have something called IP address, which, and I have explained you what IP address is. and we have my MAC address, and I have told you what MAC address is. So we use MAC address to identify our node, also the IP address to identify our node, right? And one more thing that I have to uh, explain is what is switch and what is router. So we have something called switch here, and we have a router. So switch is a device which helps the communication between two nodes within a single network segment. So switch uh, helps in uh, communicating two devices, or I can say two nodes within single network segment. So like LAN is my single LAN. It maybe it may be your house, or it may be your college campus. That single building in which a single network segment is present, in that single network segment, switch is used uh, to communicate between those two devices within the same single network. And this switch uses MAC address. So switch uses MAC address to make this communication happen. Okay. And what is router? So in our current this diagram, we don't see router anywhere, right? So where do we use router? First of all, uh, you can see that our IP address is of 4 octets, and 4 times 8 is 32. So basically we have 32 bits which are used to represent my IP address, right? So total possible unique IP addresses are 2 raised to power 32, which is something around 4 billion, right? So around 4 billion unique IP addresses are available. And when uh, when this all was being invented, when people were inventing the network and these IP addresses, uh, initially it was thought that let us assign uh, different or unique IP address to every single device on this world. But that is not possible, right? Because we can have billions uh, devices on this in this entire world. So it is not easy to uh, assign unique IP address to every single device. That's why something called private IP and public IP came to the picture. So private IP address is something which many nodes can have at the same time, but at some condition. Those two nodes should not be a part of same network segment, right? So if you have a particular LAN network here, and you have some devices here, and it has an IP address, private IP address 10.10.0 10.10.1, let's say. So this same private IP address can be taken by some other device which is in some other LAN network. So let's say this is LAN 1 and this is LAN 2. So some other device which is in some other network segment can have the same private IP address. So private IP address is not unique actually. It is unique within same network. So private IP address is unique within LAN, within same LAN, or I can say within same LAN. So since we have a limited pool of IP addresses, and we have something called private and public address, but public IP address, it is unique throughout the world, unique throughout the world. But public IP address is not assigned to nodes. Public IP address is not assigned to these nodes. Public IP address is actually assigned to the router. Public IP address is actually assigned to a router. Now what router is, I haven't explained yet, but I think it is now right time to explain what is router. So within a LAN, this is a computer device. Let's say computer device 1, and this is another computer device 2, C2. This is C1, this is C2. So let's say these two computers wants to communicate. If they want to communicate, and if they are within the same LAN network, then we know that within the same LAN network they have different private IP address. So its private IP will not be same as private IP address of this. This may be IP1 and this may be IP2. So this IP1 is not equal to IP2, that we are sure, because they are in the same LAN network. So they can communicate using the private IP address only, right? But let's say this computer C1 wants to communicate with some other computer C3 which is not present in this LAN network but present in some other LAN network, LAN 2. So let us assume this is LAN 1 and this is your house, and LAN 2 is, let's say, your college campus, and there is some computer C3, and you want the communication to happen between C1 and C3, right? And this C3 also has some private IP address, right? And it may happen that IP address of this C1 is same as IP address of C3. It may happen because they are of different network, and each network is free to choose whatever private IP address they want to choose for their nodes. So to make this communication happen, a router comes into play. So we have a router. Which connects to LAN network. Router connects to LAN network. So this C1 cannot directly communicate with C3. It has to first communicate with the router with which it is connected. The router which is connecting these two, LAN 1 and LAN 2, this C1 has to go to this router and tell it that I have this much private IP address, this much MAC address, and I want to connect to this C3 computer. Then this router will convert its private IP address to public IP address. Basically, this private IP address will map to public IP address of what? Of router. So in the entire world, the number of router will definitely be less than the number of end devices, which are your computer, laptops, or anything like that. So number of routers are limited. So, and since we have a limited pool of IP addresses, so we can assign a unique IP address to every single router in the entire world, and using that IP address, we can map uh, the private IP address to public IP address while communicating inter LAN networks, right? So for inter network communication, we have to first convert the private IP address into public IP address, and this method of this the technology through which this private IP address is mapped to public IP address is called NAT, network address translation. Network address translation. So all those routers which are enabled with this NAT technology can help inter-network communication between two devices which are not of same network. So that's why we have private IP address and the public IP address. So router uh, helps in communication the across the network segments, right? And it uses IP address for the communication. So your switch is used for communication within your LAN, and your router is used for communication across your LAN, right? And your switch uses MAC address, your router uses IP address for the communication across the LAN network. So now you must be clear of what is a private IP address, what is a MAC address, what is LAN, what is switch, why are we using switch, and also what is a router, right? One thing that we still want to discuss is what is network IP address. So to answer this, we should answer another question, like how exactly we are assigning these private IP address. So how, let's say I want to I have a setup at my house, and I have some end devices, some laptops, some computers, and how exactly the private IP addresses to those devices are assigned? Which IP, who chooses those IP addresses? So for that, so this is our question. How do we assign IP addresses, private IP addresses? This is also, the answer to this question is also a part of a topic called subnetting. So subnetting is the answer to this question. So we'll discuss what is subnetting, or there are two approaches of subnetting, and I will discuss only one of those approach, which is practical and which is used nowadays. So there are two approach of using subnetting. One is classful and one is classless. Classful is not used nowadays. Nowadays only classless addressing is used. Classless addressing in short is also called CIDR, which stands for classless inter domain routing. So we are going to discuss this subnetting, and the approach which we are using for subnetting is CIDR approach. It is classless address routing approach. So it is not like that we are free to choose any random IP address for the private IP, any random address for our IP, private IP. So there is an organization, or there are set of there is some set of standard rules which are written by the name of RFC 1918. So according to RFC 1918, we have these three blocks of IP addresses: 10.0.0 to 10.255.255.255, and one more block is 172.16.0.0 to 172.31.25.25, and a third block is 192.168.0.0 to 198.168.255 to .255. So these are some three blocks of IP addresses. So if I want to assign a private IP address to my device, I have to either choose from this range, or this range. Only these three ranges of IP addresses are available to choose to assign for my private IP addresses. Alright. Now, one more thing that I want to tell is there is something called subnet mask, and something called networks address. Now, when you are given a private IP address, you are also given a subnet mask associated with it. Let's say this is your IP address 10.10.0. Let's say 10.10.20. So this is your private IP address. Let's say this is your private IP address, and along with private IP address, we have something called subnet mask. Subnet mask tells us which part of this IP address is used to identify its network's address. Let's say your subnet mask is something like this: 255.0.0.0. So this 255 means all the bits are set, all the bits are 1. So from leftmost position till rightmost set bit, we will count how many bits are set. So we have contiguous bits which are set, and rest all the bits are unset. They are 0. So all those bits which are set will go to private IP address, and will check for those IP address, and whatever the area in my private IP address covered by these set bits comes to the network identification, comes to the network address. So since this 255 means the first octet is my network portion, and rest comes to my host portion. Now what do you mean by host? Host means the device or the node which is getting the private IP address, right? So all those IP address which have same decimal value in the first octet will come to a single network, will come to a single network segment, and all those um, networks which have different this we have which have different value in this first octet will come to different network segment, right? And if your subnet mask is not 255.0.0, if it's something like this, subnet mask is not this but it is 255.255.00, then you will consider first two octet for the network identification. So let's say I'll give you two IP addresses. One is 10.20.10.20 and another is 10.20.10.24 and other is 10.10.10.12. Out of these three private IP address, and this is the subnet mask, let's say, for this as well as this IP address, then I can say that its first 16 bits are set. So I have to check for first 16 bits in my IP addresses to identify the network address. So in this first 16 bits have value 10.20 and this also have 10.20, so they are same. 10.20 and 10.20 are same, which means these two IP addresses are of same network segment, and this is not same with these IP addresses. So this is of some different IP address, this some different network, this is from different network segment. And the first address which we get so basically I have chosen this 10.20 for the network identification, and if I turn all the values to 0 in the host address in the host side, so 10.20.0.0, this will be my network's IP address. This is my network's IP address, of course network's private IP address. So here you can see that in our LAN diagram we have IP address this and this, and its network IP address is something like this. So its first 24 bits are for network identification, and the rest bit which are 0 are for host, are for to that how many number of host will be there in that network. So from 192.168.10 until 192.168.1255, how many hosts we have? 255 hosts, right? But the first address is reserved for network address, and the last address, which is 192.168.1.255, is reserved for the broadcasting IP address. So broadcasting something in which we broadcast our message to a group of nodes or all the nodes in the network. So this is something which we will not discuss here. So the first address of the network is assigned to the network IP address, is called network IP address, and rest of the address here .1, .2 and .3 and then .4, .5 till .255 will be assigned to these nodes in the single network. So this is also uh, a reason of using private and public IP address. So in private IP address, we choose the network of an IP address. First, some all the bits which are set in my subnet mask will correspond to network address, and rest of the bits will correspond to my host address. So these the ranges that are used for which are reserved for using private IP address, they have also subnet mask. In this first block of IP addresses, we use /8 subnet mask, in this we use /12, in this we use /16. What does it mean /8? It means first 8 bits should are set, which means this first 8 bits which are set correspond to network address. In this first 12 bits are set, which means first 8 comes from here, and rest the 4 bits are taken from the second octet. They correspond to the network address. In third block, the subnet mask is of 16 bits. 16 bits are set from the leftmost side. So these 2 octets are covered for the network address. So it is not always true that we will use the entire octet for the subnet mask. We can use some of the bits also. So in /12 notation, we have used 8 bits, entire bits from the first octet, but for the second octet we have used only the 4 bits to get the network address. So these 3 blocks of IP address are only on the option for us to choose for the private IP address, and they are enough. They are enough for us. So now we know what a LAN network is, and why are we using private IP address, and how computers communicate within a LAN network. So within a single LAN network, if a computer wants to communicate, they can just use private IP address, and this private IP address can be same to some other device which is in some different LAN network. But if this device want to communicate with some other device which is not a part of this network, but a part of some different network which can be in some other country, or it can be somewhere else in the world, for that we need router. So router connects to different LAN networks, and for that we need public IP address. So the public IP address of router is mapped with the private IP address of this nodes which want to communicate. So when we send signal when we send message using router, we send private IP address as well as MAC IP address of source as well as destination. We'll tell the router that this is my private IP address of source, this is my MAC address of my source, and please convert this private IP address to IP address, public IP address, by using your public IP address, and send this message to some other computer which has some private IP address, something like this, or some MAC address, and the same that LAN network we will also have some router. So according to that IP address of that node's private IP address will be converted to some public private IP address. And we know what switch is. Switch is for communication within network. Router is for connection across the network. MAC is fixed, it never changes for any computer. IP address is variable, it changes based on your location. Private public IP address are the concept of private and public IP address is brought because we have a limited pool of IP address, right? And one more thing that I want to discuss is that the router which we are discussing about here is is this router is this router same as those Wi-Fi routers which we are using nowadays in our homes? Well, the answer to is yes as well as no, because the Wi-Fi router which we are using in our homes nowadays, those Wi-Fi routers provides three functionalities. It provides the functionality of a router, the router which we discussed here in this uh, lecture, as well as the functionality of a switch, as well as the functionality of a wireless access point. So the Wi-Fi routers that we use nowadays in our home have switch within it, router within it, and wireless access. So wireless access point is used for to make wireless connections, because we don't want to we don't have to connect our mobiles and laptops to our router through a wire. We can connect them wirelessly. So wireless access point is used for that, and switch within my Wi-Fi and router, which is used for the connection within my uh, LAN networks. So at your home, you have your phone and you have your laptop. If you want your phone and laptop to communicate with each other, they'll just use the private IP address and they'll use the switch functionality of your Wi-Fi router. But if you want to communicate with your friend's laptop or mobile phone, then the Wi-Fi router will use the router functionality, and it will convert the private IP address to public IP address by using network address translation. And your Wi-Fi router will have some public IP address which will be mapped by the private IP address of your mobile phones or laptop. So that was all about uh, these. So we have covered subnetting, we have covered IP addresses, we have covered MAC addresses, and um, we have also covered one approach of subnetting, that is classless addressing. So I have only discussed the classless addressing. Uh, so the approach in which we can have any number of set bits to represent the uh, network address is called classless addressing. We are not limited to choose first octet, second octet, or both first and second octet, which we can choose any number of set bits. I can also even choose the first 4 bits to represent my network address, or I can choose first two, but that must be contiguous, right? You can't choose first 4 bit from first octet and last 4 bits from the second octet. It should be continuous from left to right, right? So that was all about the networking concepts.